Welcome. Today we discuss on a new chapter, differential equation. First of all, let us see what is a differential equation. Differential equation actually is an equation involving at least one derivative, like that. Say d2y dx2 plus x plus 2y is equal to dy dx. This is an equation because two expressions are equal equation, and in that equation at least one derivative is present. In fact, here two derivatives are present, dy dx, d2y dx2. So it is a differential equation, number one. Then number two is, what is solution of a differential equation? How to obtain it? So, like ordinary algebraic equation, solution of an equation means we have to find the value of unknown variables. For example, say 2x plus 3 is equal to 1. So from there we have to find the exact value of the unknown quantity x, which can be obtained very easily. This is solution of the algebraic equation. But here in differential equation, we have to find a relation between x and y and one or two constants. Just a relation between y and x. Not that we have to find the unknown variables x in terms of y or y in terms of x, not that. Simply we have to eliminate derivatives, and by integrating derivative in dy dx etc. Obtain a relation between x and y. The next is order of derivative. In an equation, differential equation, the highest order derivative present in the equation is order of the differential equation, like d3y dx3 minus 2 dy dx whole square plus x plus 2y is equal to 0. It is a differential equation because two expressions are equal, and here at least one derivative is present. So the order of the derivative is that in that equation, highest order derivative present here is the order of the, here this is third order derivative, this is first order derivative. So highest order is 3, therefore order of the differential equation is 3. So next, degree of the differential equation. The degree of the differential equation is the power of highest order derivative present is degree. Once again, it is power degree of highest order derivative present in the equation is the degree. Here this is highest order derivative. Its power is 1. Though power of dy dx is 2, but its derivative, its degree is simply 1. Provided all derivatives present, all power of the derivatives present is, say, integer. Another example, I take another example. Say d2y dx2 plus dy dx to the power half, that is square root of that, plus x plus y is equal to 0. Its order is very simple, highest order derivative present here. that is 2 here, order is 2. Its power is 1. So its order is 1. It is not that, because power of this derivative dy dx is half. This is not an integer. So its order is 2, but degree is not 1. How to obtain degree? We have to somehow make the all powers of dy derivatives to integer. In that case, it is equal to dy dx square root is equal to minus of x plus y plus d2y dx2 whole square, because it is square root. To eliminate square root 2. So in that case, all powers of derivatives are integers, and highest order derivative is d2y dx2. Its power is 2. So now we can say that order and degree, order is 2 and degree also 2. So order 2, degree 2. This type of problem is very important for competitive exam. Some useful formula. Number 1, x dy plus y dx, it is equal to d of xy. It is very simple. It is product of two factors. So its derivative is derivative of x, that is dx into y, plus x into derivative of the second part, that is dy, x into dy. So x dy plus y dx is equal to d of xy. Next one is x dy minus y dx by x square is equal to d of y by x. The derivative of that, from calculation of derivative of that, we get this is equal to that. And finally, y dx minus x dy by y square is equal to d of x by y. Using that law, rule, very easily, sometimes integration can be done quickly and easily. So last of all, I tell you one thing. Linear equation. It is a differential equation. Linear equation is simply of that type: dy dx plus p into y is equal to q, where p and q are functions of x only. Then this p and that q are functions of x only. In that case, it is known as linear differential linear equation, and its solution, to obtain its solution, it is very simple, very easy. You multiply both sides of that equation by, this is called integrating factor. Integrating factor is e to the power integral p dx. P is given here, and p dx, integrate that, e to the power that. It is integrating factor. Means by multiplying both sides by that, then left hand side will be d dx of y into that integrating factor. After that, right hand side is simply q. Now, integrating both sides with respect to x, left hand side will be y e to the power p dx is equal to integration q dx. Q is a function of x only, so this can be done easily. Another type of linear equation is there. This is dx dy plus px is equal to q. In that case, p and q are functions of y only. And this can be integrated, solution can be obtained by multiplying both sides by the integrating factor e to the power integration p dy. And this way, solution can be obtained. I will discuss this type of integration with so many problems. Now, let us take few problems. First problem. The degree and order of the differential equation d2y dx2 plus 3 dy dx to the power 3 by 2 plus y square is equal to 0. We have to find the order, degree and order of the differential equation. So, as I told you, highest order derivative present in the equation is the order. Here it is d2y dx2, second order derivative. This is dy dx, first order derivative, though its power is 3 by 2. So second order, first order. So order is simply 2. Then degree. Degree is the power of highest order derivative provided powers of all other derivatives are integer. But this is derivative dy dx, its power is 3 by 2. It is not an integer. Then we have to make its power integer. For that purpose, you have to put this in one side and they together in the other side. And squaring both sides, it will be 3 dy dx 3 by 2 is equal to minus y square plus d2y dx2. Now squaring both sides, so this to the power 3, this to the power 2 minus this to the power 2. Now in that case, we can expand it very easily. Here its power is d2y dx2 to the power 2 plus 2 y square. I'm just writing it. d2y dx2 whole to the power 2 plus 2y square d2y dx2 plus y to the power 4, and left hand side is 3 dy dx whole cube. Now this equation can be written into that form. In that case, all powers of derivatives are integer. It is 1. So now we can say its order is 2, no problem, and this is d2y dx2. Its power become 2, so degree also 2. So answer is degree is 2, order is 2. No need of, mind that, no need of that type of calculation. From here we can say order is 2 and degree, because power of this one is not an integer, so mentally you can do that. To make it free of rational fractions, we, we, we understand that we have to square both sides. So its derivative, its power will be 2. So order is 2, degree is 2. Next. To form the differential equation corresponding to 2y square is equal to a into x plus a, where a is an arbitrary constant. Arbitrary constant. Okay, this is another type of problem. One relation between x, y, and some arbitrary constants. Here, only one arbitrary constant a is there. We have to find the corresponding differential equation. The rule is very simple. First of all, you see how many arbitrary constants are there. This is only one arbitrary constant a is there. A is present twice, that is not matter. But matter is number of arbitrary constant is 1. So we get number of arbitrary constant is 1. After that you have to differentiate the relation once, because arbitrary constant is 1. First of all, you simplify it. 2y square is equal to ax plus a square. One arbitrary constant again. Now differentiate both sides with respect to x, so that 4y dy dx is equal to a, 0. Now the given equation is this, and this is derived equation. Derivative, after differentiating that relation, this is derived equation. Suppose this is 2, this is 1. So if one arbitrary constant is there, so we must have the original equation and one derived equation. So from these two, you have to eliminate the arbitrary constant. You see, it is now it become very simple. A is this, put it there. So put it either there or there. So 2y square is equal to a. A means 4y dy dx. A into x plus 4y dy dx. It is equal to 4xy dy dx plus 16y square y dy dx whole square. Now this becomes a relation between x, y and derivative, and no arbitrary constant is present. So this is the differential equation corresponding to that. So once again, I'm discussing. First, observe how many different arbitrary constants are there. If it is 1, then differentiate both sides with respect to x. So get another relation. Now from original equation and the derived equation, eliminate arbitrary constant, and that will give you a relation involving x, y, dy, dx, etc. This is the corresponding differential equation. So if it is two arbitrary constants are present, you have to differentiate both sides two times, twice. So you get three relation. One is given and other two are derived equations. So from these two and one, three relation, you have to eliminate the arbitrary constants A and B and get a relation like this. One very important problem from there in different competitive exam, only this thing is given and find the order and degree of the differential equation. So this can be simplified as 4y into x dy dx plus 4y means 4y square into, oh, this is in, sorry, very sorry, this into dy dx plus 4y square into dy dx and whole square. This is the differential equation. No arbitrary constant is there. Question is, what is order and degree of the differential equation obtained from that relation? Case is that highest order derivative present is dy dx. It is also dy dx, its whole square. So order is 1. And then degree, derivative is dy dx, its highest power is 2. So degree is 2. Without calculation of that, we can obtain directly, we can say from this relation what is order and what is degree, because one unknown is there, so its order will be 1. That's all. Always it's one unknown. It is also a, so one unknown is present. So order always that quantity 1. And degree, arbitrary constant A, its maximum power. Arbitrary constant is, here you see this is x into a, this is a square. Highest power of arbitrary constant is 2, so degree is 2. But one thing you have to remember, after simplifying the given relation to the simplest form, then only you can say its order is this and degree is that. Okay. Next, from the relation x minus a whole square plus y square is equal to a square, where a being arbitrary constant, obtain order and degree of the differential equation. It is simply, you see, it is nothing but a equation of circle. Its center is at a comma 0 and radius is a. A is arbitrary, that a is arbitrary constant. From that relation, you have to find the corresponding differential equation, and from there you obtain order and degree. So simplifying this, we get x square minus 2ax plus a square, and that a square will be cancelled, plus y square is equal to 0. So here also we see only one unknown parameter is there, a. So can be obtained, differential equation can be obtained by differentiating both sides once with respect to x. So that 2x minus 2a plus 2y dy dx is equal to 0. So that we get 2 can be cancelled, y dy dx plus x is equal to a. So value of a is this. So equation of corresponding differential equation, we have to eliminate a from the given relation, this and that same, and derived equation. From derived equation, a is equal to that. So equation of the corresponding differential equation is x square minus 2ax minus 2a means y dy dx plus x plus y square is equal to 0. This is the corresponding differential equation. Because here x present, y present, dy dx present, so differential equation. From it, order and degree, you see, it is maximum order of derivative present is only dy dx. So its order is 1 and its power is 1 and no other derivatives are present. So power of all derivatives are integers. So order 1, degree 1. Now from here, how can I calculate without calculating this, how can I say that its degree is 1, order is 1? I told you, first of all, simplify the given relation to the simplest possible way. It can be written as that. This square cancels. So it becomes this. So in the given relation, only one unknown is present. So order is 1 and a is present linearly. Degree is 1. So from here we say its degree is 1, order is 1. So without lot of calculation we can say that. Our next problem, from the relation y is equal to a into e to the power x plus b, a and b are arbitrary constants. Find the order and degree of the corresponding differential equation, and options are given 2, 1. I told you first term is order, this is degree. Second one is 1, 1. Third one is 2, 2. And fourth one is 1, 2. We have to find order and degree of the differential equation, and given that a and b are arbitrary constants. Actually, from there we see that it is it involves two arbitrary constants. So order will be 2, but I told you we have to, first of all, you have to simplify it to its simplest possible way. This can be written as a e to the power x into e to the power b. So that a e to the power b into e to the power x. And the terms within the first bracket all are constant, arbitrary constant. This is constant, this is constant. They together is a constant. So this can be written as c into e to the power x, where c is an arbitrary constant. So relation become y is equal to c into e to the power x. So it involves only one arbitrary constant and its power is also 1. So its order and derivative both are 1. So this is correct option. We can verify it by calculating it in detail. From the relation, you see, this is the relation. So dy dx is equal to a e to the power b, e to the power b into e to the power x. Now we have to eliminate the constant a and b. So this is a e to the power b, this one. This is from this and that we have to eliminate this one. So dy dx is equal to, it means it is equal to y by e to the power x, that is e to the power minus x. So that e to the power x dy dx is equal to y. This is the corresponding differential equation corresponding to that. It involves only one derivative dy dx, its power is 1. So very easily we can say its order is 1, degree is 1. So 1 is answer without, and that can be said without any lot of calculation. From there I can say that its order and degree are both 1. Next problem. The differential equation corresponding to 2y square is equal to a into x plus a being arbitrary constant. We have to form the differential equation, and after that we have to find what is its order and what is its degree. From the given relation, we see that only one arbitrary constant is present. So we have to differentiate once only. So order must be 1. And you see a present in the equation, a means arbitrary constant. It is actually ax plus a square. So it is quadratic in nature. So its degree is 1. Highest degree of arbitrary constant is 2 after simplification. So degree is 2 and order is 1. So this is answer. This is answer if only order and degree of the corresponding differential equation corresponding to that relation is asked to answer. Then this. And now here the problem is to find the differential equation corresponding to that. A is arbitrary constant. So we see that only one arbitrary constant is present. So we can differentiate both sides only once with respect to x. So that it is equal to 4y dy dx is equal to a, that's all. So value of a is equal to that. So corresponding differential equation is 2y square. Put value of a is equal to a means 4y dy dx plus a square into x. So a into x, and a square means 4y dy dx whole square. And actually this is the corresponding differential equation. No arbitrary constant is present, and it is a differential equation. Its order, you see, derivative present dy dx, this is dy dx whole square. So order of the differential equation is 1, and degree of the differential equation, from there we can say it is 2. So order is 1, degree is 2. Acha, next problem. The differential equation corresponding to family of parabola whose vertex is at 0, 2 and axis of the parabola is positive y-axis. Acha, so the problem here is, in previous problems, a relation between x, y and unknown parameter or unknown parameters were given, but here it is not given. Only thing is that given that one family of parabola is there, whose vertex is at that point and whose axis is positive y-axis. So this is 0, 2 is the vertex of the parabola, and its axis is positive y-axis, means towards that. So our parabola is that. Its equation can be written as, it is of the type x square is equal to 4a y into something, y plus something. So its equation is x square is equal to 4a into y minus 2, because that point is 0, 2, y minus 2. So this is a parabola, equation of parabola, and it is told that family of parabola. Family of why family of parabola? It is, you see, a is an unknown parameter, a is a constant. For each value of a, you get a parabola of same nature. That's why it is called family of parabola. But here only a is the unknown parameter. From the now simplify first, you simplify it. X square is equal to 4ay minus 8a. Only one parameter is given, only one parameter, which is a. So we are allowed to differentiate only once with respect to x. So 2x is equal to 4a into dy dx. So we get, this is 0. The dy, we get a is equal to 2a is equal to x by dy dx. 2a is equal to that. So from the given curve, this, now try to eliminate this or that, try to eliminate a, which is x square is equal to 4a, it is 2a. So 2 into x by dy dx into y minus 2. That is x square into dy dx is equal to 2x into y minus 2. This is the differential equation corresponding to the family of parabola. Vertex is that, axis is that, and this is answer. Just 1 minute, I verify the answer. So you see, one x can be cancelled. X dy dx is equal to 2 into y minus 2. This is correct answer. Achha. Today, let us stop. Next day, this is a big chapter. Uh, we take 4 or 5 classes or more. And I request you, if you feel that it helps you, please share it and subscribe it. Thank you.